Hi everyone, welcome to Technology. On today's session, I'll be walking you through Introduction to Version Control System and Gate. Alright, let's see what is version control. A version control, also known as source control, is the practice of tracking and managing changes to software code. A version control system, also known as VCS, are software tools that help software team to manage changes to source code over the time. All right, so as you can see in the diagram, this is a source code, version 1, version 2, version 3, version 4. The new version is always the head. That's why we call it master in the GitHub or main. So now you can see the first version, which is the first dot. The project can be either in HTML or CSS or JavaScript or any other languages. This is your first code. So it's either it can be in the remote repository or local repository. Remote repository mean is in the cloud, and local repository mean right in your computer, right in your local computer. All right, so you can see the source control. This is the version control system. This is how it works. When you have your first code, and if the first code have a problem, you can branch it. That's what we call branch. You take a clone, it's like the same thing, you clone it on the side, you fix the bug, either you delete it if there's anything wrong with it, or fix the bug and merge it back to the main production. Nothing should mess on the master line. That's the production line. So if you want to work on the code, you branch it to the side, you fix the bug and merge it back, and it becomes a new version or bug fix. So on this line, you can see how it keep going. But if there's no problem, you can have the first version, and you have a second version, and you have a third version. And if you want to add more version to it, because there are many software upgrades these days, even on the one you use on your phone, the one on your TV, every other application that require you to update. That means they either fix the bug or they added more features to it. So in case they want to have more features to it, all you need to do is to clone the main project again on the side. That's what we call branch. Then you're gonna add more features to it. Maybe you want to have the login feature, you want to have any other new features to it. That's what we call branch. And when you're done with it, you merge it back to the master branch. So every changes from 1, 2, 3, this is what we call version control. It takes every record, every changes that you make is right there. Let's assume that the version 3 is working, and by the time you release the version 4, there's a problem with it. You can actually revert back, which is called rollback, to the previous version that was working perfectly. That's why we use version control, and that's actually help in the software industry. All right, so let's go over and talk about issue before version control. We have issue before version control. So let's go over them one after the other. So let's imagine that a developer A, which I'm going to refer to as this guy, started a software company and creates a code for software apps. Because to have a software company or to have a product, you're going to start with something. So that's the first step. Maybe you want to develop some application, you have to set up the first important modules that can stand by themselves. We can call that version 1, which is the software code. So everything is ready as a first step. We can call that proof of concept. Maybe a client need a product, you have proof of concept ready, then you show it to the client like, hey, is this what you need? This is what we're gonna start from. That's like foundation. Then you check it out. If everything works fine and you see like it's something that you want to continue, then that's when you can hire more people to it. So the issue we got before version control, as the company grows, they hire more developers to enhance the features of the software. Developer A shares a source code copy with each new developers. So now the company grows, they want to add more options, they want to have more features to the software. That means they need to hire more developers, right? Because one developer cannot complete a big project. You need to have multiple developers, and all these developers, they are not on the same location. They might be in a different country entirely, running on different time zone. So let's assume, as a developer, hey, you hire more developers, so you got developer B, developer C, and D. So the first thing you're gonna do is to share the source code with them. That's why you have version one, right? Which is the this one that you started with. You need to share the first version to developer B, developer C, and D, and assign a task to them. You can say, hey, developer B, you need to add a login feature. Developer D, you need to add a cart feature. Developer D, you need to add maybe the basket feature or something like that. So everybody will have the original source code. So now the problem is, let's go over and say developer B does its own part and has the feature and forward it to developer A. So remember, they have version 1. The three of them have version 1. So when the developer B finishes his own part, it send it down to the developer A. Everything is being manually changed because right now this guy already added to this version 1, so we can no longer call it version 1 anymore. So it's going to be version 2. Send it back to the developer A. Developer A is going to check it, and if everything fine, it's going to merge it to the version that he has already, and that will become version 2. So that's what you see here. So let's go over and see as the problem continue. Developer A will then verifies the changes, and if all looks good, it will merge the code to the main software code to be version 2. That's when people, the end user, can possibly see what is going on the software and probably update to see the new option. So that's version 2, right? And remember, developer C and D only have version 1. They never had the changes that this guy already added. The problem starts when developer C also completed his own task and submit the changes to developer A. So developer A will then verify the fixtures and manually integrate the changes with version 2 and then upgrade it to version 3. So now remember, this guy finished his own version, which is called, it can call it version 3 because it doesn't have the upgraded version 2 already. So he have to send it down to the developer A, which is the middle guy. So this guy will verify the version and match them together manually, and before it can now send it down to the main code, and that will become version 3. Remember, we also have developer D right there, who is also working on his own task, and developer D would not have the changes that already been made on the source code because he only have version 1. He only is going to add his own task to it. So let's go over and say, so like I told you before, similarly, when developer D task is done, it will submit the features code to the developer A, who will also verify it and manually integrate the changes with version 3 and upgrades the software to version 4. So the thing is, this guy manually upgrades all those versions, match them together. That means you have to wait for every developer to send down their own task, and it's going to verify it and merge it and manually before version can be upgraded. All right, so let's see the disadvantage of version control in all this process. Versioning was manual. Every version have to be sent over to developer A, to this guy, and he's gonna verify it and send it out or push it out to the main production before version can be upgraded. That's manually changed. Everything, because right now everything have to be sent down to this developer A. That means if this guy is not available, you won't be even able to merge your code or move on to the next stage. So let's check out. Team collaboration was a time consuming and ethic task. You can work together as a team. Every other developer have to work and connected with only developer A, who is going to merge the code manually. That's not good enough. No easy access to previous version. So remember, developer A only share the source code version 1 to every developers. Then when they're done with it, they have to send it back to developer A to merge it. The next guy don't have access to the previous version. If there's anything wrong and they want to go back to the previous version, they don't have it. Then multiple version took a lot of space because every time you send a new version, that's another gigabyte. And every changes that they add to it, you adding more gigabyte to it. You see, this guy, let's say the first code is 2 gigabyte. You send that to this guy, 2 gigabyte, 2 gigabyte, 2 gigabyte, they all have 6 gigabyte. And remember, the first code is 2 gigabyte. That means it's 8 gigabytes in total. Then when this guy finishes on side, he's gonna send 4 gigabyte. Remember, he has a 2 gigabyte, and whatever features that he added to it, let's assume it's another 2 gigabyte. Then he's gonna send it back to this guy. So he's sending 4 back, 4 back, 4 back. So it's taking a lot of space. That's like a clone. You send it the same thing back to this guy. That's take a lot of space. That's why the multiple version took a lot of space. So let's go over and talk about advantage of version control. By the time we have version control, the versioning is automatic. Team collaboration is simple because every developer are able to work together and they can have access to the source code directly. So developer A is going to have access to what developer B does have access to. And if developer A make changes or developer B make changes, all what the other developer needs to do is to do git rebase, is to pull the new version down to their own system and they can have it. So easy access to previous version. Now, if there's a problem, they can have access back to the previous version, just like I showed you earlier on. So only modified code is stored across different versions and saves storage. The version control right now is only gonna save the changes. It's only gonna keep the changes they added to the first gigabyte that were being given to them. It's not saving the same code. It's only gonna save the difference on there. All right, so let's go over and talk about types of version control system. We got distributed version control system, which is called DVCS, and we got centralized version control system, which is called CVCS. All right, so let's talk about what is called distributed version control system. So on the distributed version control system, one does not necessarily rely on a central server to store all the versions of the project files. Every developer clones a copy of the main repository on their local system. This also copies all the past versions of the code on the local system too. Therefore, the developer need not to be connected to the internet to work on the code or make changes. So basically, under the distributed version control, you can download a copy. You're gonna connect to the internet, then download it to your local repo. Your local repo means on your personal computer. That means you're gonna have access to the previous code. You're gonna have access to all the code. Download it on your computer, add changes, do whatever you want to do to it, then commit it. Commit means save, or you can say push. You're gonna commit it and push it down to the remote repository, and the changes will be matched to the source code right there. And every developer can have access to the source code to all the version. So every developer clones a copy of the main repository on their local system. That means they have this main source code on their local repo. They can work on it and push it on there. But that doesn't happen on centralized version control system. All right, so let's go over and talk about centralized version control system. On centralized version control system, one has single copy of code in central server. There's only single code right here. Every developer need internet to be able to connect to the remote repo, make their changes on there. So developers will have to commit their changes in the code to central server. So every changes have to be made on internet. they do not have that code on their local system. And on distributed, you can actually connect to the repo, download the code on your system, which is called local system or local repo. You don't have to have internet on distributed version control system. That means you can have yours, make changes, and only connect back to send the repo back when you're ready. So committing a changes simply means recording the change in the central system. So on the CVCS, when you make changes, when you commit it, means you save it. That means the changes will be effective on the master line. All right, so let's go over and talk about difference between DVCS and CVCS. On distributed VCS, everything except pushing and pulling can be done without internet connection. Every developer has full version history on local hard drive. Committing and retrieving action is faster since data is on local drive. Not good for storing large file when binary in nature. This will increase the repo size at every commit. If a project has a lot of commits, downloading them may take a lot of time. So under distributed version control, everything except pushing and pulling, which you need internet to do, you can do every other thing without internet connection. Every developer have full version history on their local drive. That means you can download every history on your local system and make changes to it. Committing and retrieving action is faster since data is on local drive. If you need any information, since you already downloaded the copy on your local drive, you can have access to it. So it's not good for storing a large file which are binary in nature because remember, you're downloading every copy on your local drive. Project that has a lot of commits, downloading them may take a lot of time. So let's talk about centralized version control system. So it needs a dedicated internet connection for every operation. Remember, you can do nothing on it except you are connected with the internet before you can be able to have access to the centralized version control system. Developers just have the working copy and no version history on their local drive. So developer only have the working copy. That means the copy they're working on, that's what they're gonna have access to. They don't have access to the previous version because they can't have anything downloaded on their own local repo. So committing and retrieving action is slower since it happened on internet. So committing mean when saving and retrieving mean when downloading. Action is slower since it happened on internet. Sometimes you don't have to connect to internet to do your job. So you can do that with centralized version control system. So it's good for storing large files since version history is not downloaded. So not dependent on the numbers of commit. All right, so let's go over and talk about what is Git. So Git is a DevOps tool used for source code management. It is a free and open source version control system used to handle small to very large projects efficiently. Git is used to tracking changes in source code, enabling multiple developers to work together on non-linear development. All right, so this is the reason why we use a Git. Git is the most popular tool among all the DVCS tools. Out of all the distributed version control system, we have Git because we have a Mercurial, we have Paphos, but Git is the most popular one. And that's the reason why we have different type of Git repositories. So you're gonna be hearing more about GitHub, which is what we use in this course. There's a Bitbucket, which is also Git repository, and there's also GitLab, which is also Git repository. As we call distributed version control, every developer will have access to the GitHub. They can download, copy on their local system, either Bitbucket or GitLab. They're all working as the same thing. So that's why we're using Git today. All right, so basically, that's all about introduction to version control system and Git. So right now, you know why we're using Git and you know what is called version control system. So this brings us to the end of this section, guys. and I hope you learn. Thank you.